So here is a worked out example of solving a quadratic equation that isn't in the friendliest format to begin with and involves factoring the quadratic trinomial where the a, or leading coefficient, isn't 1. So 6.6 number 9 as an example may look something like this. 4a squared equals negative 8a plus 5. So we want to get our quadratics to equal 0 so that we can use the zero product property. It's called a quadratic because the highest exponent is 2. When we are solving a quadratic, and in this case, we're still working on the factoring method, we want to have our a, our leading coefficient, the number being multiplied by the squared term, to be positive. So I'm not going to subtract 4a squared, but rather add 8a and subtract the 5. And do that on both sides to keep the equation equal. It's not that you can't have it be negative, it's just then you'd have to factor out the negative. So to avoid an extra step, just make the squared term the positive one. All right, so now we have our quadratic equal to 0. There is no GCF, so that's always the first thing you want to check. So we're stuck with this a value, this leading coefficient of this quadratic trinomial being not 1. And in that case, what we need to do is separate this middle term and create a four-termed expression where we can use a factor by grouping method, if possible. You will actually occasionally later in other courses have four-termed expressions that the grouping won't actually work. So in any case, we are going to figure out what works. Now, when I was back in school, we would set up our factorization and we'd say, okay, well, we want the first times the first to be 4a squared. So I could put 4a and a, and I want the last term to be negative 5. So I could put a 5 and a 1. And then I know that I need it to be negative, and so one of these has to be negative. So maybe the 5 is negative and the 1 is positive. And then you check, and you go, okay, 4a squared plus 4a minus 5a, that's negative 1a. That's not going to work for the 8a. Okay, well, what if I made this the plus and this the minus? And try it again, still won't work. When you check it, what if you made the 4 and the 1 actually 2 and 2, because that also multiplies to 4a squared. And check again whether this works. And it turns out this does. But again, you might have had the minus here and the plus here at first. That one. So there's a lot of guess and check, although it is possible. A surefire way to make these work out with less guess and check going on is the AC method. So the AC method is where you have a quadratic in the form ax squared plus bx plus c, x being the variable, in this case it's an a, it could be any letter, and you multiply the a and the c together. In this case, 4 times negative 5 would be negative 20, and that's what your two values need to multiply to. And you add to your b, which in this case is positive 8. Make sure you have your signs accounted for. So this is actually the same process you do when a is 1, except because a is 1, it's just your last number and your middle number that end up being what you need to make it work for. So what multiplies to negative 20 and adds to 8? So you might think, okay, well, 4 times 5, one of those being negative, is what I multiply to get to 20, but that doesn't work for the 8. So how about 1 and 20, one of those being negative? Still doesn't work for the 8. 2 and 10. Okay, well, if I make the 2 negative, then I do have a sum of 8, and I will multiply to negative 20. So I'm going to do negative 2 and 10, or I could do 10 and negative 2. It really doesn't matter the order. And for this example, because I think it'll illustrate other important concepts, I'm going to go ahead and do the negative second, meaning I'm going to do 4a squared, and I'm going to separate this 8a into 10a and negative 2a. So I have the exact same expression, just one simplified compared to the other. So it'll have the same answers. Now I have 4 terms, and when you have 4 terms, you want to attempt factor by grouping if possible. So we split the expression in half, and we factor each half. So the GCF for this left half would be 2a. 2a times 2a gets me the 4a squared, and 2a times 5 gets me the 10a. So again, just making sure that when I apply the distributive property, I still have the same expression. And this next one, we always take out the sign. So I'm going to take out a 2. Oops, 2 does not go into, sorry. We're going to take out a 1 because that's the GCF of 2 and 5. And what I'm left with is 2a times negative 1 is that negative 2a. And the negative 1 times positive 5 would be that negative 5. So be careful when you have a negative, because that will change that last sign to its opposite. The other thing to note is that if you're ever stuck about what the GCF is, these should always match in order to use that factor by grouping method. So factor by grouping, you have this common factor. So we're going to factor it out. So we're going to take 2a plus 5, factor it out, and what remains is 2a minus 1. I like to think of this as the common factor and then the leftovers. And it works by thinking about 2a plus 5, that quantity, being distributed to 2a, and the 2a plus 5 being distributed to the negative 1. So you can always check your work with every single step, which is awesome. So now we're going to use the zero product property. The zero product property says that 0 times anything will be 0, or anything times 0 is 0. So I can set either factor to 0. I can set both factors to 0, in fact, and find the value of a that will make the whole side equal to 0. So undo my addition or subtraction, and then undo my multiplication or division, and I get an a of negative 5 halves. Or here, I get an a of 1 half. So those are the two values. So I do want to mention that whenever your a is not 1, you do need to do the a times the c, your grouping. And what will always happen is that one or both of your answers will end up being a fraction, because one or both of your factors will not be 1, because they're both 1, then you'd have a 1, not another number. All right, so if you have any other questions, feel free to message me, and I'd be happy to do another video or explain in more detail. All right, have a great day. Bye.